Bytes and byte arrays are like tuples and lists, except instead of containing arbitrary objects, bytes and byte arrays contain bytes, 8-bit words of data. An 8-bit word of data can hold up to 256 different values, and this is sometimes a very convenient thing. In particular, it's convenient for converting strings, and this is where you'll see it used often. You'll see it used for other binary things as well, but it's oftentimes used for converting strings. And we have a great example of this right here. This is a text file that I created for this purpose, and when I created it on my Mac, it had this lovely little pattern of international characters that makes a little picture. It's a little viral thing that had been floating around on Facebook that I got. And I thought it would be great for illustrating this problem because there are some circumstances where you cannot display it and it doesn't look right, or if you try to read it as ASCII data in Python, you'll get an exception error. And so I loaded it up on the PC that I'm using here, and I saw this and I went, oh, drat, it's not pretty, it doesn't look like it. But in fact, this is a great illustration of the problem because this particular system is not handling the UTF-8 international characters properly, whereas my other system was. They're both running the same software, they're both running Eclipse, they're both running the same version of Python, and yet here we are trying to display this file here and it looks like this, whereas on my Mac it looked different. And you'll see in a moment, we'll show you here, because we're going to convert it in a way that it will display here. And we're going to use Python to do this. So this is what the file looks like here on this PC. And if you're using a different operating system and you actually see the pretty fancy characters, just shh, don't tell anybody. And the example will still work just fine. We'll start by making a working copy of containers.py, and we'll call this containersworking.py. And I'll just close this one and we'll open the working copy. And we're going to start by opening the file, and we'll call this file in, we'll open, and it's called utf8.txt. Open it for read, and we're going to set its encoding as UTF_8. And this is the exact character string that you need to use. This is meaningful inside of Python, and that tells Python that when it's reading this file, that it needs to read it as UTF-8 and ignore whatever the default encoding is on your system, which is almost certainly something different than UTF-8. UTF-8 is a really, really useful encoding. When the Unicode people came up with Unicode, it's this double-wide character set that doesn't work right in normal ASCII systems or normal 8-bit wide text contexts, and they tried to get the whole world to adopt it, and the whole world didn't adopt it. And so they came up with UTF-8, which is a version of Unicode that works in 8-bit encoding scenarios. So the first 127 characters of it works exactly like ASCII does. And so you can set your encodings to UTF-8 safely, and it'll work just fine with normal ASCII code. And then it has this clever system of setting high bits in order to tell the system that it needs a couple more bytes to represent a particular character. And it all happens kind of transparently behind the scenes if your system is properly implementing UTF-8. And these days, most web browsers do handle UTF-8 just fine. But a lot of, desktop systems don't. And this one here that I'm working at obviously doesn't. So we're opening this file as UTF-8, and we're telling it that the encoding is UTF-8 and for it to ignore its default encoding. And we're going to go ahead and open an output file. I'm going to call this UTF-8.html because we're going to open it in the browser, even though we're not going to put any actual HTML in it. And we'll open that for write. We're going to set up a byte array, and we'll call it outbytes. Initialize a byte array with the byte array constructor. And a byte array is a mutable list of bytes. So it doesn't hold any other kind of object but bytes. And we'll start iterating through the file for line in, file in, and then we're going to immediately iterate through the line for character in line because a string is an iterable object. And we're going to use the ORD built-in, if ord of C, and that gives us the integer equivalent of that character is greater than 127. So there's 128 values in UTF-8 that are just normal ASCII, and they're 0 through 127. So if this one is higher than 127, we're going to do something special with it. And otherwise, we're just going to append it to out bytes. And we're going to say out bytes dot append ord of C, like that. And then if it is greater than 127, we're going to do this fancy thing here. Out bytes plus equals. When you use the addition operator on a mutable container type, it has the same effect as appending, but you can append more than one element at a time this way. So what I'm going to do here is I'm going to create a bytes object. And bytes are immutable arrays of bytes. And I'm going to encode a string. The constructor of bytes will accept a string with an encoding. And so the string is going to be this XML entity with the ampersand and the pound. If you're familiar with XML entities, they look kind of like that, where inside of here you can put a decimal value that'll be interpreted as UTF-16, which is the normal Unicode. And so in there, I'm going to have a format, and I'm going to use this format here, 04 decimal. I know this is all looking very complicated. I told you this line is where all the magic happens. And I'm going to use format ord of C. And then the bytes constructor is going to have an encoding. And that encoding is UTF-8, because we use UTF-8 for everything wherever we can. And so now what we've done is, if the character is outside of the normal ASCII range, we're going to encode it with this XML entity, which can be used in an HTML context, and that'll allow us to display our fancy little picture. Otherwise, if it's not greater than 127, if it's in the normal ASCII range, we just append it to our out bytes. And now we have an out bytes byte array, which has all of the characters for our string. And now all we need to do is to turn it into a string. We'll call it outString, and we'll use the string constructor, and we'll construct it out of out bytes. And guess what? We're going to use encoding equals UTF-8. Now all we need to do is to print it to our out file, print outString, file equals fout, and we'll print it also to the screen here so we can see it. And we'll print the word done. So this will read our UTF-8 text from our file that we're not able to read on this system. Go ahead and save this. No catastrophe happens. This will read our UTF-8 text file, and it'll read it with the UTF-8 encoding, and it'll write it out to our UTF-8 HTML file. And for the characters that are outside of the normal ASCII range, it's going to replace them with an XML entity. And that's really all that we're doing here. So we've saved it. We're going to run it. And it looks like I've got a typo someplace here. Yes, right there. I needed an S. That's all right. We'll save that and we'll run it. And there we have our fancy string. So this stuff here got converted to UTF-16, and these are the Unicode values for each of those fancy characters. And now if we refresh our file system, because Eclipse doesn't like to do that for us, and we open this up in the little browser inside of Eclipse, there's our fancy little picture. And so this is what it looked like in the text file. This is a UTF-8 file. It has some interesting characters in it. And so we weren't able to see that on this system. And by encoding them with the Unicode XML entities, we're able to see them. And there we have it. So the way that we did this is by using a byte array. The beauty of a byte array is that you can operate on character data, because characters are bytes. And a byte array is mutable, so you can insert things, you can change it up. And all we did here was we basically used it as an accumulator. As we went through the string with the bad data in it, if we found an element that we needed to operate on, we pushed all of these characters onto the byte array using the bytes constructor, and appending them to our out bytes, which is a byte array. Otherwise, we just appended the regular character. If it was within the range, we just appended the regular character. And so these characters here just got appended in the normal way. But these characters, we ended up using these XML entities, which represent the Unicode characters, and we got our little fancy guy to display just the way that we needed him to display. So that is a very common use of byte arrays. Byte arrays are a very effective way to do things like this. You'll see an example very much like this one in our example code later on in the course.